Good day. Today what we're going to be talking about is we're going to be talking about acids and bases. And in that what we're going to talk about is also conjugate acids and conjugate bases. And ultimately what we want to do is we want to determine whether a solution is going to be acidic or basic. And we'll do this by calculating what's called the pH. All right. So to start out with, the very first question we have is it says, write the formulas for the conjugate base for each of the following acids. So you can identify that these are going to be acids because you have a hydrogen as the cation. So this would be this is by sulfite. This is the hydronium cation. This is the hydrogen phosphate, and this is nitric acid. And what we want to do is we want to write the conjugate base for these. And so in order to write the conjugate base, what has to happen is they have to dissociate and give up a proton, right? So if this gives up a proton, what is the conjugate base? Well, the conjugate base is going to be just the sulfite. All right? So you can see now that this charge of the entire species is going to be -1. If it loses a hydrogen, which is going to be a +1 charge, then what happens is we have the sulfite, which is going to be a -2 charge. The hydronium cation, what happens there is that when that loses a hydrogen, all right, so this is the acid, it's going to donate a hydrogen. What is left over, or for the conjugate base, is going to be the water. All right? So let me review again. Let me state it a little bit clearer. What I write in pink is going to be the conjugate base. Here we have the hydrogen phosphate. If it loses a hydrogen, which is going to be +1, then this entire molecule is going to be reduced by 1. And so this becomes the phosphate for 3-. This happens to be nitric acid. It's a very strong acid. If it loses the hydrogen, all right, then what is left over is NO3-. So it's very simple to come up with a conjugate base for these acids because all you simply do is you remove a hydrogen. All right, if you remove the hydrogen, you're removing the +1, and then you adjust the charge to be as such. All right? Okay, for this problem, what we're going to do is we're going to write the formula for the conjugate acid for the following bases. So this is going to be the opposite of the previous problem. And what we want to do here is these are bases, and thus what's going to be added to them is going to be a hydrogen, thus making a conjugate acid. All right? So if we add a hydrogen to this, we get HSO4. All right, now remember the charge of this whole thing is going to be -2. Oops, I forgot my -2. All right, that'll be a -2. Sorry, I apologize for that. Now, if we have a -2 and we add +1 to that, then this becomes -1. All right, for the cyanate, the cyanate, if we have a hydrogen to this, that's going to be a +1. The +1 is going to cancel with the -1, so this becomes just HCN0. All right, this is hydroxide, OH. If we happen to add a hydrogen to this, all right, this becomes H20, and it's not going to have a charge. The chloride down here, once again, if we add a hydrogen to that, make that 0 over a little bit better. If we add a hydrogen to that, that +1 is going to cancel out with the negative, and thus we get a neutral charge. So notice, these are going to be our conjugate acids. All right, these are the conjugate acids in yellow marker, and all we've simply done is we've added a hydrogen to the bases we happen to have here. All right? Okay, now that we've looked at both acids and their conjugate bases, and we've also looked at bases and their conjugate acids, let's determine whether something is going to be acidic or not. Now, in order to do that, we have to do a few calculations. All right? One of the calculations we have to do is what's called the pH calculation. And so pH is equal to the -log of the concentration of the hydronium cation or the acid. All right? And how you're going to do that on your calculator, now everybody's going to have a slightly different calculator, right? Most people happen to have a Texas Instrument. I typically use a Casio, but I happen to be using my wife's Texas Instrument, and I'm going to sort of walk you through how to do some of these calculations, all right? So let's say, for instance, we happen to have a concentration of the hydronium cation or the acid And that's going to be equal to 6 times 10 to the minus 12. All right. So how do you enter this into your calculator? Well, first thing you're going to do is you're going to type in the minus 3. Now this happens to be under, on a Texas Instrument, this happens to be under the number 3. So on your Texas Instrument keypad, if you happen to look underneath the 3, you'll see a negative. You don't have to type in the parentheses, you just push that negative. All right. So you push the negative. All right. Then on your calculator, you should have a button that has the log. And so you're going to push the button that has the log on it. Okay? That will artificially put in a parenthesis. All right? You don't have to type the parenthesis, but it will put in that parenthesis. All right? Then next, what you'll do is you'll type in the 6. All right? Now this is where it gets a little different with Texas Instruments. How do you enter in this times 10? Well, on a Texas Instrument, that is going to be an EE. Now, so you're going to want to look for the button that is an EE. All right? Sometimes it's above the 7 or 8. I don't have an 83 or an 81. I happen to have an 89. It's a little bit more advanced copy of this. But you're going to want to push that EE button, and that represents times 10. Next, you're going to push your negative button again, just as it is, under the 3. All right, it should be under the 3. All right. Then you'll type in 12. All right, you'll type in 12. Close the parenthesis. That's going to be very important that you close that parenthesis. All right, so what I've got written in blue is what you're going to want to type into your Texas Instrument calculator. If you have a Casio, it's going to be a completely different operation, all right? What I have in yellow is what actually appears. Now, when I go through and do this calculation, what I end up getting is I end up getting a, oops, not a negative, that's taken care of there. I get 11.22 is the pH that I report from my calculator. That's what it gives me. Now, this is going to be basic, all right? This is not going to be acidic. So if you happen to have a pH and that happens to be less than 7, that is going to be acidic, all right? If you have a pH equal to 7, that's neutral, all right? And if you happen to have a pH which is going to be greater than 7, that's basic. All right? I think the hardest thing that most students have with this is going to be typing this into the calculator. You have to use some kind of practice. Go to YouTube or a channel that will walk you through how to do this if you're having some problems, or you're more than welcome to help me. It's going to be much more difficult for me to help you if I'm not familiar with your type of calculator. As I mentioned, I typically use a Casio calculator, the one, and I'm not promoting Casios or anything along those lines. It's just what I used when I was in high school or in colleges. I typically use Casios and not Texas Instruments, and so I'm a little bit more comfortable using a Casio. But some people will actually, it's in that times 10, which gets a little interesting. But if you hit the EE button, which is what that represents, is the times 10, you should be doing pretty well. Okay? Now, what if we happen to have an H3 plus concentration, so an acid concentration of 1.4 times 10 to the negative ninth, and that would be constant. The square brackets here represents that it's going to be a molarity, moles per liter. Now, how do we find the pH of this? Well, the pH of this is going to be we're going to use the exact same equation. pH is equal to the minus log of the concentration of 1.4 times 10 to the negative ninth. All right. If we go through and do that calculation, this pH, oops, what did I do there? pH is equal to minus, I apologize. This pH here is going to be equal to, I got 8.85. Now this is going to be a unitless number, all right? Now this pH happens to be, once again, above 7, and so this is going to be referred to as basic. It's going to be referred to as basic. Now, let's say we do a different kind of problem, all right? Let's say, for instance, we're not given the concentration of the H+, all right? We're not given an acidic concentration. What we're giving instead is we're given a concentration of a base, all right? So if we're given the concentration of a base, what are we going to do there? Well, that gets a little bit more difficult, and we're going to do a problem just like that right now, all right? Let's say that you are given a concentration of a base, all right? So that happens to be our base. We're given a concentration of the base. Our concentration of that base is 5 times 10 to the negative 12, and that's going to be moles per liter. So how do we find that? Well, we can't use pH because we don't have the concentration of the H+. What we're going to have to use instead is we're going to have to find what's called the pOH, all right? This is going to tell us how basic a solution is, right? This equation is going to be essentially the exact same as pH in that it's the minus log, but what we don't put in is we don't put the concentration of H+. What we put in instead is the concentration of the base, all right? So we'll walk through this step real quick, or real carefully, how to do this. So we're first going to find our pOH. All right, so our pOH is equal to the minus log of the concentration of the OH, and in this case it happens to be 5 times 10 to the minus 12. All right, that is going to give us an answer of 11.30. Now, we can't determine necessarily yet whether this is going to be an acid or a base because we're basing that off of what our pH is, not the pOH, all right? So how do we find the pH from the pOH? Well, there happens to be, you guessed it, another equation. That's right. And so our pH plus the pOH is equal to the number 14, right? The number 14. Thus, our pH is equal to 14 minus our pOH, all right? So if we plug our values in for this now, we have 14 minus 11.30. And if we solve that, we are going to get a pH of 2.70. So now we have a pH which is less than 7, and this solution is going to be acidic. So the next example we're going to look at is we're going to look at the concentration of OH. So once again, we're given the concentration of the OH, which means we have to find the pOH and not the pH. All right, and ultimately what we want to do is we want to determine whether this is going to be an acidic or basic solution. And the concentration of the OH is 4.5 times 10 to the negative 2 moles. And I'm sorry I've been leaving this M out. It's just simply moles per liter. We're going to find our pOH, and that's going to be equal to the minus log of 4.5 times 10 to the negative 2. All right? That is going to equal 1.35. Once again, we can't determine, or we're not going to determine whether this is going to be an acidic or basic solution. We're going to first look at the pH, and that's equal to 14 minus the pOH. And so that is going to be equal to 14 minus 1.35, and that gives us a value of 12.65. Now this happens to have a pH greater than 7, and so this is going to be referred to as a basic solution. So it's just going to be basic, which is all the question asked for. All right. Before I start the problem, I want to do a quick review of some of the important equations that are found in acid-base chemistry calculations. All right. So I'll do a quick review of some of these calculations and these equations and how to use them and when to use them and why to use them, and we'll start from that. So the first one we're going to look at is the pH equation. Now this one we've already looked at. This is going to be equal to the minus log of the concentration of the H3O plus, or the concentration of the acid. The next equation we have is going to be POH. And this is equal to the minus log of the concentration of the base, right, of the base. Now, if you're given a concentration of a base, you can't find the pH. You have to find the POH, right? So if you're given a concentration of a base, you got to find the POH. So this is going to be the concentration of the OH, which is going to be the base. So once you found the POH, how do you find the pH? Well, that is another equation that becomes very important, and that is that the pH plus the POH is equal to 14. So once you find the POH, you can put it into this equation and solve for the pH. Now the very last equation we're going to use is going to be the concentration of the acid times the concentration of the base is equal to 1 times 10 to the minus 14th. All right. That becomes, once again, another very important equation to use. All right. So now those are all fairly, and how this works is, let's say you're given the concentration of the OH. You want to find the concentration of the acid without finding the pH. You simply then would take 1 times 10 to the minus 14th and divide it by the concentration of the OH, or vice versa. If you're given the concentration of the acid and you're looking for the concentration of the base, you would take 1 times 10 to the minus 14th and divide it by the concentration of the acid to find the concentration of the base. All right. Now, what if we want to work backwards? All right. And what I mean by that is, let's say that the problem gives you a pH. All right. So you're given a pH and you want to find the concentration of the acid. All right. So let me just repeat that for clarity's sake. Let's say that you're given a pH. So you happen to have a pH is given, all right? And what you want to do is you want to find the concentration of the H3O plus. Now the reason I left these two equations up here is what we're looking for here, what you're ultimately looking for, is the opposite of this, all right? So you're given the pH and you want to find the concentration, right? So the pH is given to you in a problem and you want to find the H3O plus, so the concentration of the acid. Well, you have to do the opposite. So what that equation is it's H3O plus concentration, that's what you're looking for, is going to be the opposite of that. So the opposite of the log is the 10-2. So it would be the 10 to the negative pH. Now if you happen to have a Texas Instruments, it's like an 83, an 81, 89 in my case, my wife happens to have a TI-89. And in order to use those TI calculators, once again, this is going to be working for the TI. If you have a different type of calculator, you got to figure out how to take what's called the anti-log of that. And so for a TI, which is what a lot of students have, you simply do the 10 caret the minus sign, which is below the 3, and then you type in, the pH value that's given in the problem. All right? All right. Okay. It's helpful to be familiar with these equations, but also know how to use the equations. That also becomes extremely important as well. All right? When I come back, we'll work on the very next problem. Right. Now that we've done that quick review on acid and base equations, let's use that knowledge to solve this question. The question is, complete the following table. All right. So what we have up here for columns, we're going to have the concentration of the acid. This is going to be the concentration of the base. This is the pH, and this is whether the solution is going to be acidic, basic, or neutral. All right. What you see in blue is what is given to you. All right, is what's given to you. And I'm going to put the answers in pink. All right. So for the first one, we happen to have an equation. We have a pH of, sorry, let me get to my notes. All right. So what we have here is we have a pH of 10.10. Now remember, if the pH is going to be greater than 7, all right, the solution is going to be basic. Since this is greater than 7, this is going to be a basic solution. All right. Now, if I happen to have a pH of 10.10, all all right, I have to find the H plus concentration, all right? So how do I do that? Well, we just went over that example a few minutes ago where the concentration of the H3O plus is equal to 10 to the minus pH, right? So remember, you put it, if you happen to have a Texas Instrument or a TI calculator, you're going to type in 10 caret negative 10.10. And when you do that, what you get is you get 7.94 times 10 to the negative 11th is what you get, all right? Now, from there, how do you find the OH concentration? How are you going to find that? Well, I'd given you an equation just a few minutes ago of the concentration of the H3O plus times the concentration of the base is equal to 1 times 10 to the minus 14th. Now, if we substitute this into there, so once again, we're going to be solving for the OH. The OH is going to be equal to 1 times 10 to the minus 14th divided by 7.94 times 10 to the negative 11th. And what we get now for a concentration of the OH is going to be 1.26 times 10 to the negative 4th is what we get for that. All right, I'm going to erase this real quick. So that should be two. I think the hardest thing is to know, we got a lot of equations in this chapter and how to use what equation where, and then also please be very comfortable with using your calculator. That becomes very valuable. If you don't know how to use your calculator, it's not going to do you any good, right? So go through, watch, make sure you know how to use your calculator. All right. For the next problem, if we have something that's going to be neutral, well, if something's neutral, that means it's going to have a pH of 7. If it has a pH of 7, if you do the concentration of H plus, if you're looking for that and you have a pH of 7, we're going to do it the exact same way we just did down here. We're going to 10 to the minus 7, so this is going to be equal to 1 times 10 to the minus 7th. If it's neutral, that means that the concentration of the acid and the concentration of the base are going to be exactly the same. So this becomes 1 times 10 to the minus 7th is how you do that one. All right. Now, for this one, we're given a concentration of a base. All right. So we're given the concentration of a base. All right. And what we can do is we can find the H plus concentration from this. All right. So if we do the H plus concentration of this, we have H3O plus is equal to 1 times 10 to the minus 14th divided by 1 times 10 to the minus 9th. And what that's going to give us is give us 1 times 10 to the minus 5. All right. Now, if we take the minus log of this to find the pH, we will find out that that's going to be 5. Oops, I kind of took over my spot here. I'll get that erased real quick. All right. So now, if we have a concentration of a base of 1 times 10 to the minus 9, we just showed that the concentration of the acid is 1 times 10 to the minus 5th. We take the minus log, remember how to go from pH, or from concentration of acid to the pH is going to be the minus log of that value. That's going to be 5. And if 5 is less than 7, that means that this is going to be acidic. That's going to be acidic. Now we have this one problem right down here. We have 11.3, all right? And once again, if we want to find, I'm going to write it, I'll write it right over here. If we're going to find now the H plus concentration, we know that the H3O plus concentration is equal to 10 to the minus pH. So you put 10 caret minus 11.3. That will give us 5.01 times 10 to the minus 12. All right. Now, we know that this is going to be basic because the H plus concentration, because the pH is going to be greater than 7. Since the pH is greater than 7, we know this is going to be basic. But I want this space over here to solve the problem, all right? Now, we're looking for the OH concentration. OH is going to be equal to 1 times 10 to the minus 14th divided by our H plus concentration we have there, which is 5.01 times 10 to the minus 12. And what we end up getting here is approximately 2 times 10 to the minus 3. All right. Now, we know that 11.3 of a pH is going to be greater than 7, as we just got done saying. And so we know that this is going to be basic. All right, that's going to be basic. I know that was a lot of calculations, but I know you folks can do it. If you happen to have any questions on this, please let me know. All right, have a good day. Goodbye.